As I said, in part 2, we're going to have some fun with polynomials. All right, we want to sketch a graph. Now, here's what we know about the graph. It's odd and negative. Oh, yeah, what does odd and negative look like? Like a cubic, but flipped. But it has 5 real roots that cross the axis only 3 times. Now, that makes it tough. So what I start off with, how many times it crosses the x-axis. Now, they don't give me any value, so I'm just going to make it cross here, 2, and 3. There's my x-axis. This is where it crosses. Now, what next we're going to take a look at is the odd function. It's odd, so it starts up, ends below. And it has to cross 5 times. I mean, it has to have 5 real roots. So the 5 real roots means, since it only crosses 3 times, there must be multiplicity. Okay, so there must be multiplicity here. So what do? I take a look here. I want to make sure it has to be odd. So if I take a look at here, make this M2, this M2, this would have to be what? M1, right? Very good. Now, it has to be 1 if you didn't know, because remember, this touches twice, 2 real roots, 2 real roots, 1 real root. And they have to be an odd number, so it can end, 1 goes up, 1 goes down. So if I cross here, bounces up, and because it's M1, it goes down. And there's my graph. Now, see if you can do another one. There's a lot of ways you can do this. Here's my x-axis, 1, 2, 3. I can make this M1, this M2, and let's see here, and this M2. What's that going to look like? Goes through, bounce, bounce, and down. There's another way I could do it. There's another way we can do this. It's sky's the limit. Make this M3. M1, M1. Still adds up to be 5. Still an odd number, so it goes through, but it's going to wiggle, go through, and down. So there's lots of ways we can actually graph this one. In fact, come up with a couple ways on your own. You know, have fun with it. Be original. Be creative. All right. Now, the last one we're going to take a look at is, given this polynomial, we want to find the roots. Now, this is going to be a little bit harder. If I'm given this polynomial, we want to find all of the roots. So what we're going to have to do is divide. Now, looking at the graph, they do give us a couple roots. It looks like one of the roots is 2. And it looks like I have another root at -2. Here and here. Now, the other ones look like they're between -2 and 1, and the other one looks like it's between 3 and 4. Now, I want to find their exact roots. So here's what we're going to do. If I'm given 2 of them, I can reduce my polynomial by using synthetic division. So if I take my polynomial, -2, 1, -2, -8, 8, 16, and I divide that by the first 0, my first root, that's going to give me 1, give me 2, 0, -8, -16, which gives me -8, which gives me another -16, which is 0. Now, this is now a cubic graph. But watch what happens. I divide it again by my other root. 1, -2, -2. 4 gives me -4. 8, which gives me 0. So I went from a quartic to a cubic, and now what we have is a quadratic. X squared minus 2x minus 4 equals my function, my reduced polynomial. Now, if I want to find the roots, set this equal to 0. Now, the problem is I can't factor that. Can't factor. So how do we solve this one? Yeah, that's right, quadratic formula. X equals -b plus or minus the square root of -2 squared becomes 4 minus 4a and b, -4, all over 2 times 1. We get x equals 2 plus or minus the square root of, this becomes 4 plus 16, which is the square root of 20 over 2. And those are both our answers, the 2 plus or minus. Now, try this one more time. Okay, you want to make sure you know how to do that one, okay? And that's it for your notes for tonight, and we'll see you guys in class tomorrow.